So combinations and permutations are sometimes really hard to distinguish. So there are two ways to play poker. Well, I mean, two different methods of poker. One is cards, and one is dice. One is a combination, and one is a permutation, which is weird because it's basically the same scoring system. So let's talk about cards. In cards, does order matter? Okay, explain. Here's some sometimeses. Well, so if I have a straight ace through 5, and you have a straight 5, 3, 2, 1, 4, do we have the same hand? Yes, right? Because you can reorder the cards. So with cards, order, there is no order. Okay? Are there duplicates? Wait, isn't there more than one, too? Okay, so in cards, there are no duplicates. And the reason that's the case is because each card has a suit. That's the main difference between cards and dice. With dice, does order matter? Why? Can I rearrange my dice without changing my value? Can you rearrange the dice? That's a good point. What if I have 5 dice and what if I have 1 dice and I roll it 5 times? If I have 5 dice, are they all the same dice? No, they're different. They could be different colors. They could be different sizes. Even if they're identical dice, they're still different. Does that make sense? Yeah, I mean, if you had 5 identical twins, identical quintuplets, if you change how they're arranged in your minivan, or whatever it is you decide to drive, is that a different situation every time they change seats? But they're identical in every way. So maybe that's a good analogy. If you had 5 identical twins, does changing their order represent a different situation? No, but, well, wait. Hang on. If you change their order, you still have 5 people in seats, and it's a different arrangement. Okay, that's what I meant to say. So it counts as a different possibility. And if you think, if you put 5 identical people in a van, how many ways can you do that? Well, certainly more than one. If there are only 5 seats, and you say only one way, that doesn't make any sense. It's only one. There's only one way to do it, so that they're nice. With dice, are there duplicates? Yes. So there are duplicates, and if there are duplicates, by definition, it has to be a permutation. So order matters. Now, what about if we roll the same dice 5 times? Well, then we have a first roll, a second roll, a third roll, and a fourth roll. So that's obviously a permutation, because 2, 1, and 1, 2 are different. But what if I roll 5 dice at the same time? Is it still a permutation? Well, do duplicates exist? Yes, so it needs to be a permutation, so we need to come up for a reason why it's a permutation. Okay? Well, you can think of the dice as having names. They might be identical in every way, but you could have a dice named Colette. So, Colette, when you listen to this, 18 penguins. I think she'll get it. So, if you have 5 dice, then there are duplicates, which means it's a permutation, but I still can change the order of the dice, right? But that doesn't change the dice's names. This is not working today. I'm having a wardrobe malfunction. So when you roll dice, when you flip coins, whenever you actively do something to gather data, okay, most of the time it's going to be a permutation. Granted, if I roll a 1, a 2, a 3, and a 4, and I have those 4 dice, I can mix them up all I want. But it doesn't change the fact that the dice named Yori had a 1, and the dice named Kelton had a 2. Even if I change that order, each dice still has the same number. So whenever you're looking at dice, think of it as an n-digit number. I don't care what dice you put in the first spot, but it always has to be the same dice, the red dice or the green dice. Does that make sense? Order matters. So what you do is you name all of your dice. We'll just name them 1, 2, 3, 4, and 5. And no matter how we roll it, I always pick up dice 1 and I put it in the first spot. Does that make sense? Okay? So that's why this one is a combination and this one is a permutation. Now that you understand that, let's muddy the water horribly. Okay. So we have 5 dice. How many options are there for the number on dice 1? 6. Dice 2, 6, 6, 6, 6, which is 6 to the 5th, which is, yes, Satan's zip code. Actually, I think 66666 is a zip code in Michigan. Really, I think it is. Seems like I heard that once. Okay, everybody understand that? Okay, this is a permutation with replacement. If it was without replacement, then we would have done 6, 5, 4, 3, 2, 1. But that would mean that whatever your first number was couldn't be your second number and so on. So what you might want to ask yourself is, do duplicates exist? Yes, therefore permutation. Okay. So what about 5 of a kind? How many options are there for the number on dice 1, 6? Okay. Well, let's say that my first number is a 3. What is my second number going to be? A 3. So how many options are there for that digit? Just 1. Does everybody get that? Everybody's all right with that? Cheyenne? Okay, let me do that again. You understand, so I'm going to be creating a number on dice. My first dice has 6 sides, right? So there are 6 choices, and let's say that I get a 3. Okay? Well, I know that 5 of my dice are the same, and 1 of them is different. So I'm trying to get 5 of a kind. Well, if my first dice is a 3, what is my second dice? It's also a 3, and maybe let me lock this so I can reuse it, because this might actually help. Oops. Okay, so if my first one is a 3, how many 3s am I going to roll? 5 of them, because the second or third question on there says, how many 5 of a kind hands are there? Sorry, 4. No, 5, right. So there are 6 ways to get my first number. But once I have my first number, what do I know about all the others? They're all 3s. Does that make sense? Okay. Well, this one could have been any number 1 through 6. How many numbers could this have been? There's only one number it could have been. It could have been the number 3. What about the next one? It has to be a 3. Does that make sense? Okay. So, how many ways are there? 6, which makes sense. How many five-of-a-kind hands are there? All ones, all twos, all threes, all fours, all fives, or all sixes? No, so this row is the actual value on the dice, and this is the number you multiply. So 6 times 1 times 1 times 1 times 1 times 1. Yes. Okay, so let me move this right here. So this is the number of possibilities, and this is the actual dice. This will probably help. I didn't do this in any of my other classes, but it'll probably help. Okay, so let's now look at 4 of a kind. What does a 4 of a kind look like? 4 of the same, so let's pick a number. Let's say 4 twos. So 2, 2, 2, 2, and something else. A 1, not a 7. There are no 7s. So that is a 4 of a kind hand. Everybody agree? So for dice number 1, how many possibilities were there? 6. This could have been anything 1 through 6. Once I've chosen that dice, then this one had one option. Does that make sense, Cheyenne? Because if that's a 2, this has to be a 2. So I don't get to pick it. 1. Oh, Jackson's onto it. Hang on a second. Okay. 6, 1, 1, 1, 5. Why 5? It can't be a 2. If it's a 2, this is not a 4 of a kind hand. It's a 5 of a kind hand. So the last one has to be different from the other 4. But if I multiply those together, I get 30. That 30 is the number of possibilities if my single number lands on dice 5. That's what Jackson was saying. He's saying, wait a minute. Is this the only place to put the 1? No. I could have put it anywhere else, right? So, this is my permutation for 1 orientation. Okay? But there are a lot of combinations of orientations. Yeah, it is. Makes me feel smart. Okay, so let's think about this. We have 2 groups of numbers. Okay? I have a group of 4, and I have a group of 1. Does everybody see that? Groups are always arranged by identical numbers. Okay? This is not the only way to arrange the groups. But in this particular arrangement, there are 30 ways to fill it in using different numbers. If I use all 2s, then I could do 1 through 5. If I use all 1s, then I could do 2 through 5. If I did all 3s, then I could do 1, 2, 4, 5. Well, and 6. I missed the 6s. So, that is my permutation, but there is also a combination of arrangements. When you calculate the combinations, you might want to put that away. It's distracting you. When you calculate the combinations, you need to calculate how to arrange all of the groups except 1. And that'll make more sense in a minute, but just trust me on that. So, I either ask, how many ways are there to put 4 dice in 5 places, or how many ways are there to put 1 dice in 5 places? So it's either 5 choose 4, or 5 choose 1, and those happen to be the same number, right? Combination, NCR. You have an NPR button and an NCR. NCR is for combinations, and we say choose. NPR is for permutation, and we don't say choose. Okay, so how come 5 choose 4 and 5 choose 1 are the same? 1 and 4 add up to 5, right? So This number determines how many ways there are to place the dice in a particular arrangement, and this number or that number tells us how many arrangements there are. So whether you do 5 choose 4 or 5 choose 1, you get 5. And then I take the 5 and I multiply it by the 30, because there are 30 ways for this arrangement. But I could also put the 5 here, 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 or here. So there are 5 ways to put this number. Does that make sense? So I could pick up this one dice, and I could move it to any one of those places. So there are 1, 2, 3, 4, 5 places. Likewise, I could pick up the 4 dice and arrange those, and then there would be 5 ways to do it, because 5 choose 1 and 5 choose 4 are the exact same number. Okay, so let's do 3 of a kind. So give me an example of what a 3 of a kind would look like. 1, 1, 1, 2, 4. Okay? How many ways are there to choose the first dice? 6. Second dice? 1, 1, 5. Why not 5, 5? 5, 5 would include full houses. So 5, 4. Now, this is separated into 2 groups again. It's separated into a set of 3 and then my unrelated dice. Does that make sense? Anytime you have dice that are unrelated, they go in the same group. Even if there are 4 of them or 5 of them, they all go in the same group. Okay? So, this is 6 times 5 times 4 is 120. That is the number of ways to get a 3 of a kind on the first 3 dice. Now I need to figure out the number of combinations for moving those 3 dice, for moving those into different positions. So I either do 5 choose 3 or 5 choose 2. If I'm arranging those, that would be 5. You have 5 places, and you're placing 3 dice in those 5 places. Okay? If I arrange these, it's saying you have 5 places. Where do the 2 unrelated dice go? Well, 5 choose 2 and 5 choose 3 are both 10. So this is one version of 10 arrangements. And each arrangement has 120 permutations. So there are 1,200 3-of-a-kind hands. You kind of getting the hang of this? Okay. So I'm going to skip to 1 pair because we're following a pattern. Okay? So 1 pair. Yes. So give me an example of a 1 pair hand. So 5, 5, 6, 4, you and your 7s, 1. That hand is worth 1 pair. The other 3 dice don't do anything. So how many options are there for dice 1? 6, dice 2, 1, 5, 4, 3. So that's 360 360 permutations if the first 2 dice are a pair. How many ways are there to create a pair among the 5 dice? 5. So I either do 5 choose 2, which is 10, or I do 5 choose 3, which is also 10. So if I times this by 10, 3,600. So you have a really good probability of getting a pair. In fact, it's almost 50%. Not quite. But you almost have a 50% chance of getting a pair. Okay? So, let's move on to a full house. Give me an example of a full house. Everybody agree? That's a full house. Okay? So how many options for dice 1? 6, 1, 1, 5, 1. Okay, so 6 times 5 is 30. There are 30 ways to get a full house if your triplet is on the first 3 dice. How many ways can I place a triplet among 5 dice? 5 choose 3. Or 5 choose 2. It doesn't matter which one I do. If I place the set of 2, I automatically place the set of 3. If I place the set of 3, I automatically place the set of 2. Okay? So really, you only have to place every group but one. What if I had 3 groups? If I place the first group, then I have to place the second group, and then the third group is automatically placed. Does that make sense? Okay. So there are 30 ways to get a full house on this arrangement, and how many arrangements were there? 10 arrangements for a total of 300. Now, I'm going to leave this up here because the next one is kind of confusing. Okay, it's really confusing. So I'm just going to draw a new set. Hang on, we'll get there. Let's do 2 pair. And this one really is confusing. Okay? I'll do my best to describe it, but again, my brain doesn't work this way, so I'll try. Give me an example of a 2 pair hand. Braden, you're not allowed to answer anymore. So like that. That's a 2 pair hand. How many for the first dice? 6. 1, 5, 1, 4. Why is it not 5, 1, 5? That would be a full house. Well, it wouldn't have to be, but it could be a full house, right? Okay, so how many groups do I have? I have 3 groups. So I need to place 2 of the 3 groups. Okay? So this 6 times 5 times 4 is 120. Times that by, how many ways are there to put the first group? 5 choose 2. So 5 choose 2, which is 10. And how many ways are there to put the second group? Wait. Is it 5? It's 3 choose 2. Why 3? I've already placed 1 pair. Now I need to place the second pair, and there are only 3 slots left. So 3 choose 2. And then do I need to place the last one? Well, I could, but it would be 1 choose 1. We haven't mentioned that yet, but the last group is always 1 choose 1. Okay, so 5 choose 2 is 10, and 3 choose 2 is 3, so times 10 times 3. Now, let's put it in a different order. It shouldn't matter which group I do first. So what if I place the single first? How many ways are there to do that? 5 choose 1, which is 5. Then how many ways are there to put the first pair? Not 3. 4 choose 2. So 4 choose 2 is 6. Is 5 times 6 the same as 10 times 3? Yes. But we've screwed up. Okay? And I'll do my best to describe this. Okay? Set 1 and set 2. Okay? In a full house, can set 1 and set 2 be interchanged? So if I had 3, 3, 3, 2, 2, this being set 1 and that being set 2, is that the same thing as 2, 2, 2, 3, 3. No, certainly not. But what if I'm looking at pairs? So let me back up a little bit. Let's say that this is a pair, and this is a pair. Let's say that my set 1 is made up of 2 and 2, and my set 2 is made up of 3 and 3. Okay? If I put set 2 first, 3, 3, 2, 2, okay? Can I guarantee that that is actually set 2? I can't tell them apart, right? That's a problem. Because so let's do it this way. I could do 1, 2, or I could do, so I could do 1, 2, space, 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 or I could do 2, 1, space, 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 or I could do, this isn't working very well. The fact that the two sets are the same size means that we're going to overproduce the list we want, right? Oh, here we go. Here we go. This is it. So set 1 is either 2, 2 or 3, 3, and set 2 is either 3, 3 or 2, 2. So if I list set 1 and then set 2, then I have the number either 2, 2, 3, 3 or 3, 3, 2, 2. If I list 2 then 1, I either have 3, 3, 2, 2 or 2, 2, 3, 3. Do you get that? Can I do the same thing with a full house? No, it's obvious which one is set 1, right? But because these sets are the same size, we're going to overproduce the numbers. Because if the sets are distinguishable, then they count every time. But if the sets are not distinguishable, then they count once, and then they get counted again on accident. I don't know how to say it other than that. Okay? But I can tell you this. If the sets are the same size, then you need to divide off the size of the sets. No. If the sets are the same size, then you do the number of sets P the number of sets. So in this case, 2P2, which is 2 times 1, which is 2. Which means when you have two sets of the identical size, you produce 2 times as many numbers. You count every number twice, essentially. Does that make sense? So let's say I had 8 dice, and I had 4 pairs. Okay? How many duplicates would I produce? Well, how many sets are there? 4P4. 4P4, it's not 4, it's something, it's 4 times 3 times 2 times 1. So that's 24. Okay? If I have 6 sets of 3, so I have tons of dice, 6 sets of 3, because those sets are the same size, I produce 6P6 extra numbers. So you take the extra numbers and you divide them off in the end. So I take my 300 and I divide it by 2P2, and I get 150. And that happens because the dice, each group has the same number, and you can't tell which group went first. And because of that, we doubled the number of possibilities up here, right here. I don't know if this is set 1 or set 2. It could be 1, 2, or it could be 2, 1, and they both get counted. So I need to divide it off to get rid of them. I hope that makes sense. Well, it only matters if the sets are the same size. Right, full house doesn't matter. As long as the sets are different sizes, then it can't happen. Yeah. Well, what happens is you create a list of numbers, and each number gets counted extra according to the number of equal sets there were. So if there are two equal sets, then there are two duplicates of every number. If there are three equal sets, then there are six extra, 3p3. If there are four sets of equal size, then there are 4 times 3 times 2 times 1, 24 extra sets. And you're only allowed to count each one once. So you divide it by that number to eliminate all but the one. So I hope that makes sense. It doesn't matter. Yeah, because multiplication and division commute, so it doesn't matter. Yeah, you can divide at any point. Okay, um, so let's do straights. What do we know about straights? Okay, they are in order. What are the options? I could either do 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6. There are really only two possibilities for runs. Now I just need to figure out how to arrange them. So I know whatever my arrangements are, I'm going to times it by 2. Okay, because there are really only two versions. It's either 1 through 5 or 2 through 6. Well, that's, so we have 6, 1, well, no. It's not 6. It's 2, 1, 1, 1, 1. Because it either starts with a 1 or a 2. Wait. That's a different arrangement, right? True, so let's calculate the arrangement separately, which is what we've always done. We've always picked the first number, and then we decided how many ways can that number be rearranged. So it's either one of those two. Okay, so how many groups do I have? 2 or 5? Well, let's try it. So if there are 5 different groups, then we should have to calculate all but one. How many ways are there to put the first group? 5 choose 1 times 4 choose 1 times 3 choose 1, 2 choose 1, and I don't need to do the last one. So 5 times 4, 20, times 3, times 2, 120, times 2, 240. What if we did it the other way? What if we did it Kelton's way? And we said, okay, there are 6 ways to choose this. 5, 4, 3, 2, 30 times 4. That doesn't work. Are there really 5 ways after you pick the first one? Well, the first one is going to determine whether it's this or whether it's that, kind of. I mean, if you have a 1, then you're limited. If you have a 6, then you're limited on which one. So you'd have to calculate a ton of different possibilities, and I don't even know how to do it. Okay? Well, that's where this came in. Okay? We looked at how many different straights are there. There are only 2. And then we had to mix the numbers up. So we said the first dice, the 1 or the 2, could go in 5 different places. Right? So this is dice number 1. It could go in any of the 5 places. Well, how many places could dice number 2 go in? And dice number 2 is either a 2 or a 3. It only has 4 spots left. So 120 is the number of ways that 1, 2, 3, 4, 5 can be arranged. Well, there's another 120 there for a total of 240. Okay, what about a nothing hand? A bust. A hand that's worth no points. 1, 2, 3, 4, 6. Okay? So let's calculate that out. So 1, 2, 3, 4, 6. Okay? How many of those are there? Well, I could leave out a 5, or I could leave out a 4. Could you leave out a 1? No. Could you leave out a 6? No. So there are 4 ways to do it. There are 4 versions. Now we just need to rearrange. Well, arrangement doesn't really matter, right? How many groups do we have? 5 groups. So I have 5 totally separate groups. So if this is the one I pick, and remember there are 4 versions of this, one missing a 2, one missing a 3, one missing a 4, and one missing a 5. So let's just pick this particular version. So how many ways are there to put a 1? 5 choose 1. It could go in slot 1, 2, 3, 4, or 5. 4 choose 1, 3 choose 1, 2 choose 1, and then the last one doesn't matter. So 5 times 4 times 3 times 2 is 120, times 4 is 480. Okay, so look at your homework for tonight. Okay? Bottom, yeah, 6-headed. So look at full house. There are 2 full houses with 6 dice. There's a 5-2 full house, or 4-2 full house, and a 3-2 plus 1 full house. Does that make sense? So one version is this: 3, 3, 3, 3, 4. That's a 4, 4. So this is a 4-2 full house. Or we could do 3, 3, 3, 4, 4, 6. That's a 3, 2, 1 full house. So when we calculate the possibilities here, how many ways are there to put the groups? 6 choose 2, or 6 choose 4. Okay? How many ways to do these groups? One. You pick all the groups but one. Well, no. So this one, it would be 6 choose 3 times, not 3 choose 2. Or I could do 6 choose 2 times 4 choose 1. Or I could do 6 choose 3 times this group, 3 choose 1. Either way, you're going to get the same number. Okay, look at 2 triplets. What do they call it? 2 3-of-a-kinds? I don't have my paper. 3-of-a-kind, 3-of-a-kind. Whenever you have groups of the same size, you need to divide off the duplicates. If we have 2 groups of 3, how many duplicates am I going to have? Well, how many groups are identical? 2 groups, so 2p2 is 2. Okay, what about 3 pairs? How many groups of equal size are there? 3, so I need to divide off 3p3. And 3p3 is just 3 times 2 times 1, which is 6. Because there are 6 ways to swap pairs in an indistinguishable way. Because you could have group 1, then group 2, then group 3, or group 2, then group 1, then group 3. And you can't tell them apart because they're all the same size. Okay? Good luck. I just did. Okay, roll it. Yes. Well, tell you what. I'll be nice to you. Don't look, but on the answer sheet, it has the calculations. So I want you to try it Try it, see if you can figure it out, and then check to see if your calculations are right. I have given you the actual calculations.